Okay, so what I found is the math skills need a little work, a little review. So we're going to sort of do that along the way. But I'm going to start off with some sort of techniques and some ideas and some formulas from grade 11. And tomorrow we're going to give you some brand new formulas, the big boy and big girl kinematics formulas. A little bit of formula derivation tomorrow. So you have a spot there to write down some formulas. I hope I got them all right. V bar equals D over T. VAB or V bar is V1 plus V2 or VI plus VF over 2. What do these little arrows over top of some of these things mean? It means they're vectors, yeah. The arrow means vector, but the bar, you're right, Connor, I heard you say average. The bar itself means average. Delta V is equal to VF minus VI, and I apologize for some of the quality of those. I didn't have a lot of, I was sort of cutting and pasting from other places. A equals delta V over delta T. F net equals MA, and do you remember this one? Remember what that funny looking thing is, Austin? The weird looking U with the tail? Don't remember that? It's been a while, eh? It's the Greek letter mu, Greek letter M. Although I've been told by the Greeks in town that it's pronounced me, but all my research online says that all the scientists call it mu, so I don't know who to believe. Anyways, I'm going to call it mu because that's what I grew up saying. So mu equals FF over Fn, where FF is the friction force and Fn is the normal force. I'll pause there for a second, let you get those down. Okay, so I did notice too that some people need a little help sort of working through problems. So a little tips here, some steps. Read the question once to sort of get the general idea. Read it a second time, identifying quantities and what they represent. Some people like to write them down, you know, like M equals 5 kilograms. Some people just put an M above the 5. Either way, it doesn't really matter, whatever works for you. But it's a good thing to do. Identify what the question wants you to find, like what's the question actually asking for, and work backward through formulas to develop a roadmap, if you will, sort of figure it out, right? And as you get more experience, that roadmap just sort of, you just know where to go kind of thing. It's kind of like, you know, driving to school. Eventually you just kind of do it by memory muscle. So here's the first one. An automobile has a mass of 1,600 kilograms. What force is required to give it an acceleration of 1.2 meters per second squared if there are frictional forces totaling 200 newtons? So for this one, I'll do it like this way. If you want, write down the mass as 1,600 kilograms. If you just want to put an M there, that's fine, whatever works for you. What force is required? So here's some stumbling blocks. What force is required? They're asking you for the FA, the applied force. FA. And you may not get that to the end of your sort of a little analysis. The force is required to give it an acceleration of 1.2 meters per second squared. Sometimes it doesn't come right out and say the word, what the quantity is, but you might have to deduce it or figure it out from the units. If there are frictional forces totaling 200 newtons. So in other words, the friction force is 200. Okay, so here's the hard part. Where do I start? What do I do? I'm trying to find the FA, right? Trying to find the FA. I've got FF. Do you remember, don't write this down. Do you remember this one? F net is equal to FA plus FF. Okay, and here I get into trouble as well because students want to think that that's a specific formula, but really, what does F net mean? It means the total of all the forces. So really what I probably should be doing, and I'll draw it on my car over here, you probably should do this first. FA, FF. Remember what those are called? Free body diagram? Right, just shows all the forces. You might want to put the weight force and the normal force, but they are balanced in this case. And do they have really any effect on anything? They don't. So, you know, while the people that want to have everything just perfect might want to put those down, the people who want to just get her done might ignore those, right? So with FA and FF, that's my net force. If only I had the net force, I could find out what FA is. Could I get the net force somehow? I can with the M and the A, right? So I've sort of built my little roadmap. So the first step, and I sort of didn't write it down specifically, did I? I just kind of worked you through it. F net is equal to MA, 1600 times 1.2, and if I'm not mistaken, I think that's 1800. Yeah? 1800 newtons. 1920, that sounds better. I was counting on Martin. Guess I learned my lesson. 1920 newtons. Okay, remember sort of lining up those equal signs, right? Showing your work, substitution. If you want to put units there, it's not a terrible idea. Probably a good idea, actually. And now we go something like the net force is the applied force plus the friction force. And again, net force simply means add up all the forces. The net force is 1920. We're solving for applied force. And now what about this friction? It should be negative. Why? Because the negative is a direction, right? We're really adding vectors here. But because one's positive and one's negative, they're in opposite directions. I don't need a protractor. I don't need any of that. I can just assign positive and negative just by convention. And I assign friction force to be negative. In this case here, the car is actually going to the left, which is negative, but there's no mention of direction here at all, right? So we don't really need to worry about it. The car could be flipped. So when that minus 200 goes to the other side, it becomes plus 200, right? We add it over here. And I'm not going to do this all the time, but I'm going to sort of start the first little while here, just to get your math skills back up to speed. So 1920 plus 200 is going to be 2120, isn't it? 2120 newtons. And most people like to put it that way, right? And if you want to skip this step, that's okay. I would think many of you, certainly by the end of the course, can just take that minus 200 over to the other side, punch in your calculator, and then write it like this. You should be able to do that sort of mental gymnastics. Okay, that's a grade 11 question. But again, we're reviewing here, right? Does this one look harder? You want to try it? Want to give it a whirl on your own? Okay, you guys give it a try. I'll give you a couple minutes and then we'll do it. Have a look. Object of mass 50 kilograms, so there's your mass. M is 50. Is at rest, so that's code for the initial velocity is 0. At the origin on a horizontal frictionless surface, is that important? Yeah, it means there's no friction force. At time t is equal to 0, a force of 10 newtons is applied. Fa is 10 to the object in a horizontal direction for 5 seconds. So we got a time of 5 seconds. What are the position and the velocity of the object at t is equal to 5 seconds? And if the same force is again applied at 15 seconds, what are the position and velocity of the object at t is equal to 20? Oh, that seems like it's going to take me a while to do. I don't like that. All right. So we are looking for the velocity and the position. Well, let's do the velocity first. I got F, I got an applied force, and I got the mass. If the applied force is the only force, then that is the net force. And is that true? Yes, that is true, right? All we have is Fa. Do these ones matter, the up and down? They don't matter. So the net force is the applied force. Fa is the net force. Oh, not normal. Is equal to mass times acceleration. So that's going to be 10 is equal to 50a. Divide both sides by 50, right? 10 divided by 50 is 0.2. Did you get that far? Okay, so that's the acceleration. Now you should be able to go A equals delta V over delta T. 0.2 is Delta V, and was this the part there, Austin, where you were asking me? Okay, so how do we solve that? You've got delta V divide by 5, so you're going to multiply both sides by 5. 5 times 0.2, in fact, I think is just 1 meter per second. Now, the next step is kind of optional. Delta V is VF minus VI, and this is the part that we're going to, once we learn the new equations, is going to make things a little simpler for you. Delta V is equal to VF minus VI, so 1 is equal to VF minus 0, right? Because the initial velocity is 0, which means that the final is just plain old 1. Will the delta V, the change in the velocity, and the VF always be equal to each other? Only when the initial is 0. Only when the initial velocity is 0. Okay, so I got the VF is equal to 1. So that is, I guess, the second part of A. So what about the position? How far has it gone? The formula with position in it, right, has average velocity in it. Do we have average velocity? We do not. And remember, delta V and V bar are not the same. Many of you would have seen something like this on test, right? Delta V and VF are not the same. Or sorry, actually, delta V and V bar. What's the difference between average and change? If perish the thought you got 50 on your first test, and then you got a let's make it different numbers. Let's say you got 90 on your second test. How much do you change by? Plus 40. Is that the mark that I give you? Plus 40? No. What's your average? 70. That's the difference, right? Change and average are not the same. It's funny how many times I have to say that. Well, not funny, haha, that's for sure. Anyways, V bar is VI plus VF over 2. And again, tomorrow, once you get all these fancy new formulas, all this is going to be a whole lot easier. Initial was 0, final was 1 divided by 2. So the average is 1 divided by 2, or 0.5. And now I can go V bar equals D over T, 0.5 displacement. How much time was it? 5 seconds? All right. So it travels 2.5 meters. I don't think I want to do part B. That seems like a lot of work. I don't know why, I just feel like it's not worth the value of me doing it, I don't think. Yeah, are we good there? Does this work well, trying it on your own? Well, this one's kind of tricky. How about I get you started on this one a bit? For the people that haven't done physics for a while, or ever, a father is pulling his son on a wagon. He pulls with 200 newtons of force at an angle of 25 degrees above the horizontal. Is this just screaming out, draw a picture? It should be. Okay, so we got this. 200 newtons is applied at an angle of 25 degrees. There is 40 newtons of friction present. The mass is 5. What is the acceleration? We are solving for A. How am I going to get acceleration out of a bunch of force stuff? F net equals ma. So that leads you to, okay, I got to find the net force. Okay, the net force is the sum of all the forces. We have a weight force down and we have a normal force up. But really, we're only interested in the horizontal forces, right? Now, those of you that had me for first semester physics, that was sort of multi-taught by many teachers. You got lots of different kind of formulas and stuff. I'm moving towards calling this, I think back in the good old days, I called this FH, horizontal component. Then I started realizing what was happening is people were treating it as a different force. So now I'm going to use this term, FAX, the X component of FA. Okay? On the solution pages, it will still show FH. I have not had time to go through all of them and erase them and fix them, nor will I ever. It's not going to happen. This would be then FA Y, the Y component. Okay, so it's the FAX, the horizontal component that's going sideways, and the FF, the friction that's also sideways, that sort of give me that net force, right? So step one, what's the first thing I gotta do? I'll give you a hint. Find FAX. Remember your grade 9 trig? Right? This is a right triangle. Is it always going to be a right triangle? Yeah. The x and y components are going to be perpendicular to each other. And this is adjacent, so which one is it? Sine, cos, and tan? Cosine has adjacent in it, right? Remember all that stuff? No? Maybe we should go back to this page here and put cosine theta equals adjacent over hypotenuse. Sine theta is opposite over hypotenuse. What's tan? Opposite over adjacent. SOHCAHTOA? Right? You guys know that? Who's seen that before?
That's the lady that was traveling with Lewis and Clark, right?
I have no idea. What? Her name was SOHCAHTOA? Oh, that's pretty close, though, isn't it? I think you gotta. How do you spell that, Bailey? Do you know?
Nope.
No?
Don't even ask.
Anyways.
Found a way.
Yeah, that's awesome. SOHCAHTOA. SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Okay, which tells us that FAX is equal to FA cos theta. So that's one you might want to have from grade 11 too. And the corresponding one for that, FAY, would then be FA sine. It'll all start coming back to you, don't worry. Let's go back to the problem here. It doesn't look very good that I'm going to get all four of them done today, does it? So I'll just skip that part and I'll go FAX is equal to FA cos theta. The applied force here is 200 times the cosine of 25, and now I'm going to need a calculator. Not enough solar power over here. $181.3. Okay, so what that means is of that 200 newtons, 181.3 is pulling it sideways. And now I can find the net force, FA plus FF. Oh, hang on. It's FAX, isn't it? 181.3 minus 40 newtons of friction. 141.3. I can do that in my head. Why am I doing that? Okay, so now I got my net force. What is the acceleration? F net is equal to ma. 141.3. The mass is 35. A. We're dividing by 35 both sides. 4.04. So now the question, how far is the wagon traveled after 6 seconds? We're looking for displacement, right? To get displacement, I'm going to need the average velocity. I don't have any velocities yet here at all, do I? Right? So I got to get to the average velocity. To get to the average velocity, I got to find the final velocity. To get the final velocity, I need the change in the velocity. A equals delta V over delta T. So this new value, 4.04, solving for delta V when the time is 6 seconds. Multiply both sides by 6, right? Get rid of a divide by 6, we're going to multiply. Oh, these calculators have trouble. $24.24. Because the initial velocity is 0, that means then that the final velocity is that same number. So now I got to find the average. Oh, this is going to be, you guys are going to be so happy when I show you the new formulas. So many extra steps. It drives me nuts that I have to do it this way, by the way. Yeah, it does. It's like, oh, I wish I could just show them the easy way. 0 plus 24.24 divided by 2, 12.12. And now V bar equals D over T. And I'm hoping that you're not even looking at me anymore. You can do this on your own. 6 seconds. Multiply both sides by 6. $72.72 meters. 2.5 kilogram crate, that is the mass. Let's do it this way, instead of writing them out. 2.5 kilogram crate, that's the mass, is pushed horizontally with a force of 30 newtons. Pushed horizontally. It doesn't come out and say applied force, but that's what it is, right? 30 newtons is the applied force. The coefficient of friction is 0.2. That is our mu value. Calculate the acceleration. How far does it move? Okay, what should I do first? I'm going to draw a picture. I got 30 newtons of applied force. I have some friction force, but I don't know what it is. And I've got a weight force, Fw, and I've got a normal force up. In this case, are the normal force and the Fw balanced? They are, and in other words, they are equal to each other, right? And you might remember mu is equal to F. Hold on here. Let me do the backwards root thing. To get the acceleration with the mass, I'm going to need to know the net force, right? That's going to be the last step I do, right? F net equals ma. To get the acceleration out of the mass. So in other words, I got to find the net force. And the net force here is going to be made up of the applied force plus the friction force. But I don't know the friction force, do I? So the one thing that I do have that can help me with friction force is mu. So I can use mu equals Ff over Fn. But I don't know Fn. The normal force is equal to the weight force, which is equal to mass times gravity. Do I know the 9.8 value? I do. Do I know the mass? I do. So there, this is sort of my roadmap, right? This is the order that I have to go in. And remind me from time to time, I forget that I need to show students that, because I just know what it is and I just do it, right? So you guys sort of think through that a little bit. Let me get rid of that red so you can read it better. Okay, that's the roadmap. That's the order that I'm going to do it in. So the first step is find that weight force, mass times gravity. It's almost always a good idea to find the weight force. You are going to almost always use it. So the mass here is 2.5. Gravity is minus 9.8. 24.5. And it's negative, but that only means that it's down, which means that the normal force is balanced, which is up, 24.5, positive. And now follow the roadmap, mu equals FF over Fn. .2. Friction force is what we're solving for. Normal force is our 24.5. Multiply both sides by 24.5. Right? Multiply and cancel. So that 24.5 times 0.2, 4.9. And now you have to assign that a value of negative. It's not going to come out of the equation, okay, because it's opposite. Following the roadmap tells me to do this next. F net equals FA plus FF. Applied force is 30 minus 4.9. 25.1, right? And now that I got that, follow the roadmap. Next thing to do is go to F net equals MA, and I think I'm going to be done. Divide both sides by 2.5. You're going to get pretty much 10. Okay, so that's something new, newish, newer today. How far does it move after 4 seconds? You're going to have to do that same thing that we just did, right? Exactly the same steps that are right here. I'm going to let you do that on your own. Okay, you do that on your own. I'll write the answer down here for you right away. You got a worksheet there. That's an not old, but it's from grade 11. Or that one. That's nice. Okay. So you can try these as practice. I would encourage you to do some. I apologize for not giving you any class time to work. Do as many of these as you can. There'll be a challenge. I would like to sort of do the derivations tomorrow and get that out of the way, and then I'll probably give you a couple days sort of work on problems and get your feet wet kind of thing, and then we'll do the pre-test on that. And I've got some book ones to do as well. So we're going to spend about a week sort of doing the problems with this. Okay? Mainly it'll be kinematic stuff. The forces stuff won't come into play for a bit. Okay, so try some of those. Do your best. As always, the answers are on the back. There's a link to solutions as well as a QR code. If you don't have a QR reader on your phone, get one. I will also post a link to solutions on Solutions. If I don't do that, send me an email for mine. Okay, I'll finish this off here. You should do it on your own too. You should get 80 meters.